Hello, everybody. Welcome to the panel session on satellites and non-terrestrial networks. This session I will moderate. My name is Barry Evans from University of Surrey in the UK and the 6G Innovation Centre. And you can see we have a panel which represents various space assets. From Fatima Hamdani, represents essentially the HAPS community, Anton Monk from Viasat, representing the satellite GEO, and Erwin Hudson, who represents the satellite LEO constellation. So I'm going to introduce, and then I'm going to ask each of the panelists to say a few words before we open up the session to questions and hopefully answers from the panel. So could I have the first slide? My first 3 slides essentially are going to address the situation. What is 6G? When is 6G going to occur, and what role do satellites and UAVs play beyond 5G. So I've tried to collect together here a few things that people talk about in terms of moving from 5G to 6G. So advanced services, and perhaps the most challenging of the advanced services is teleportation, transmitting the individual, transmitting the presence essentially, which requires obviously a lot of spectrum. And this is why people are looking at terahertz communications to provide that capacity. Other things I see are optical in space, more optical in space than we have at the moment. With the complexity coming along with these systems, people are talking about artificial intelligence. Also emerging is energy efficiency. It's very important to reduce the energy consumption as we move forward. People are talking about massive virtualization in a software-defined network. People are also talking about unified hybrid systems. So systems which are composed of components, different components, which can be connected together. So that is what I think 6G is about, or what other people think 6G is about that I've collected. So if we can move on to the next slide. When's it going to occur? Well, I've borrowed this slide actually from Nicolas Chabert in the 3GPP community. And we are currently at a situation of rolling out 5G and making it work essentially, and incorporating non-terrestrial assets. So I personally think this will take up until around about 2025, but we've already started research and development for 6G, particularly from the terrestrial community. And this will start now, and I doubt it will finish by 2030, but 2030 might be a reasonable situation to say we might have some 3GPP standards by then for this new 6G system. And then the rollout of 6G beyond 2030. So as the slide says, we're moving from a situation of 4G where we had interoperability into a current system where we've got integration, where we're trying to pull these things together into the future where we have a unified integrated system. I can now move on to the final slide in introduction. So what is the role of non-terrestrial networks? And what do we mean by non-terrestrial networks? We mean space assets. So going right down to drones, to high altitude platforms, to various satellite layers from LEO to MEO to GEO and so forth. What gets talked about a lot is 3D integrated networks. So networks that integrate all of these assets. GEO, MEO, LEO, HAPS, drones, etc. Maybe not all of them together, but taking parts of them to actually provide this 3D network. What is the role of satellites in the future? I don't see it changing much from the role that we have at the moment, which is coverage and resilience. And that brings up the situation of spectrum. As we move into 6G, we're seeing the terahertz community moving towards kind of a fixed high capacity very localized type service, into a 6G in the cities, and then a 6G for more rural communications. So I'd like to pose the question there, where are we actually focusing our space assets in this? Are we focusing it with the cities? Are we focusing it as a completely different system to cover the rural community? And where is the spectrum for that? Are we going to use spectrum which is used by the mobile community, or are we going to use spectrum which is completely different from the mobile community? So I think with that introduction of what is 6G, when is it going to occur, what the role of NTN is, I'd like to open up to the presentations from the panel. So I think if Fatima, if I could ask you to kick us off with your first presentation.
Barry, thank you. You've kind of opened it up and covered very interesting angles of this, and I'll touch upon some of the angles that deal with unmanned aerial platforms more within the Earth's atmosphere, going all the way up to the stratosphere. So Kraus Hamdani Aerospace, just to give a little bit of an introduction, I am one of the co-founders and CEO of Kraus Hamdani Aerospace. I'm going to share my screen a little bit. So we are building 100% electric unmanned aerial platforms, with the key being persistent, non-stop, airborne ability from an intelligence perspective, as well as comms and communication. And so at the core of that, we look at ourselves as that connective tissue between sea, land, air, and space, touching upon what Barry, you touched upon with regards to how do you create that 3D network across, or how are you bringing all of these assets? As we grow from a comms perspective of communication, there are various considerations when it comes to satellites, when it comes to unmanned aerial systems, cost, launch, recovery, future-proofing from a technology perspective. And essentially, when we look at non-terrestrial networks, traditionally the likes of the mobile operators, AT&T, Verizon, Telefonica, have depended a lot on land-based terrestrial networks to get us all connected. As these assets become available persistently, nonstop for long duration, starting with a few weeks, going all the way up to months, that's when you can truly bring in a layered network across all of different altitudes. And that's what we as an organization are striving towards. And that includes the high altitude, that includes the medium altitude, and then starting with lower altitudes. We were very recently in discussion with AT&T as part of some of the disaster management communication, extending communication. And one of the components they brought up is, if we put a certain type of base station, we can't have any asset take it beyond 1,000 feet above ground level, because then it'll interrupt with all of the other components that they have in place to connect assets. And that shines even further light that every altitude is going to play a role in enabling the networks of the future, 6G being part of it. Satellite from a LEO and GEO enablement, last mile uplink closer to Earth, and then backhaul of data, because there are different components that come in, and 6G is, from a wireless perspective, from a presence perspective, going to be necessary, especially as we look at, or is going to be an enabling technology when I say necessary. And so that's the perspective we as unmanned aerial platform providers bring in. However, there are angles of edge processing. There are angles of ability to smartly monitor these networks. We're involved with the Air Force and a swarming project that allows us to swarm based on ensuring the mesh network or the communication we're providing is optimal. Some of my colleagues here will bring up the conversation around antennas. We have a digital phased array antenna that's integrated into our 16 feet wingspan of our smallest asset that can measure anywhere from 1 megahertz to 60 gigahertz and transmit at that. It changes the game, but how and what altitude that digital phased array antenna will be flying is going to be critical. How it interacts with everything else in the network is going to be critical. We work with the DoD and government quite a lot, and the question of contested environments, denied environments, how do you ensure connectivity when things can get interrupted, even from a satellite perspective? And how do you plan for that? So those are the kind of questions that are being faced, whether we look at 3GPP or any of that standardization. How do we all come together and partner together? I'm part of the High Altitude Pseudo Satellite Alliance, HAPS Alliance, where all of us who are looking at different types of assets that can stay within the Earth's atmosphere at higher altitudes or even lower altitudes, and kind of enable what LEO and GEO assets are going to be doing from a comms perspective, and how do we all come together around that? So in terms of introduction, this is just an example of how different types of asset categories, we're not just talking about UAVs or fixed wing assets. There are high altitude balloons, there are blips, there are terrestrial networks that are all coming together. This is just an example of backhaul of data, but similarly, as you consider 6G and advanced communication, there are multiple different components that come into play. So in terms of introduction, just wanted to kind of give that as a background, that a lot of us, not just the satellite providers, but actually fixed wing unmanned aerial platforms that have the ability to fly long durations persistently nonstop, are going to be a massive game changer in this space as we look at the networks of the future.
Thank you very much, Fatima, for that introduction on the HAPS arena. Can we now move perhaps to, I think the next one was Erwin. Erwin Hudson from Telesat.
Okay, thanks, Barry.
Can we have the slides?
I had a couple of slides. Okay, thank you. And the next slide. So we at Telesat are building a large constellation of LEO satellites, approximately 300 satellites. And we've taken, I get invited sometimes to speak at CubeSat conferences, and I don't think people realize that a 700 kilogram class satellite is probably well above, kind of CubeSat category, about 5,000 watts of power. And I can remember when GEO satellites were about this big. We're building 50 landing stations around the world. We're building a family of user terminals that can communicate with these satellites. We're building a satellite ops center, a network ops center, and a cybersecurity center. And we're incorporating artificial intelligence and machine learning and lots of kind of hybrid cloud architecture features into these data centers and operation centers. And there's a kind of a picture of the satellite. It's about a meter by a meter by about 3.5 meters long, and about 15 meters tip to tip if you count the solar array. So reasonably large spacecraft, and producing, I say, about 300 of these. So if we go to the next slide. So our basic architectures, we're putting 78 satellites in polar orbit in 6 orbital planes, that's 6 times 13. We're putting 220 satellites in inclined orbits. They're about 50 degrees inclined, so they go kind of up and above kind of where the world's kind of population belt is, and come down to the kind of bottom end of the world population belt. So there's 20 orbital planes with 11 satellites each. They're up at about 1,300 kilometers. We've taken a very high technology approach. We've got global Ka-band spectrum with a high degree of frequency reuse. We have each of our inclined satellites has 24 beams, so that you can use the spectrum on left hand and the spectrum on right hand for almost 24 times frequency reuse. Direct radiating antennas, we have hopping beams that can hop between TDMA time slots, so they can kind of kind of can hop in a matter of microseconds from spot to spot. Full onboard digital processing. We essentially have, certainly by 10 or 15 years ago standards, a full-blown supercomputer on board, and we've got what's essentially a software-based payload. We have optical intersatellite links running with 4 on each spacecraft, so we connect everything together into a space-based mesh. And then the most challenging part of the whole system is not necessarily the hardware or even the telecoms. It's the Constellation network operating system. That's all of the software, the network management system, and all of the control and resource management to make the network play properly. So we go to the next slide. And so kind of thinking forward, I mean, of course, we're being quite aggressive on the technology. I mean, certainly I've been doing satellites for a long time, and we've been talking about phased arrays for a long time. We're putting something like 1,500 phased arrays in orbit, quite big, complicated ones. We talked about optical intersatellite links for a long time. And we're doing, we have 10 gigabits in each direction, which is, not super aggressive, but there's almost unlimited bandwidth at optical frequencies. So we're thinking as looking kind of forward to a second and a third generation, I think there's almost unlimited bandwidth at optical frequencies. I could see us going to certainly 100 gigabits for sure, in the next generation, and even, kind of terabit rates at some point. The payload itself, I mean, we digitize, we have a massive, compute capability, and we have D-to-A converters to turn that back into analog. There's no more real radios anymore, or cavity filters and all that stuff that we used to have in the olden days. It's all done digitally. Learning to manage the network, I mean, it becomes quite complex, and artificial intelligence and machine learning, they love complexity. Humans hate complexity, and the ability to manage these complex systems just kind of opens a door, because the definition of an engineer is a person that's trained to stomp out complexity, and we don't need to do that anymore. The launch cost, thanks to kind of SpaceX and what Blue Origin and others are doing, they're about half of what they were 10 years ago. That's really, really good. And we'd love to see that drop another 5 or 10 times. And in terms of networks themselves, I mean, we don't even think of ourselves as building satellites anymore. I mean, what a satellite's basically a router with a fuel tank and some solar arrays. I mean, it's all about the network. It's all about data. And we aren't even really building a network. We're really extending our customers' networks, up into space and then back down to, pretty much, full global connectivity, the poles, the oceans, aircraft in flight, and all of that. And so, I mean, we certainly feel like that we're pushing the technologies forward, but we have to be reasonable as to what we can achieve in the next 2 or 3 years. But as we look even forward to that second and third generation, it's pretty incredible what's out there. And I think 5G is here today, 6G is coming later. The technologies are growing like crazy, and of course, the wild card I think is quantum communications. I think I hope that in my lifetime we get to see true quantum communications where we can just transmit incredible amounts of data with zero latency and infinite bandwidth. May or may not happen, but something's going to happen for sure. So that's certainly my introduction and my thinking as to where the world might be going. We can't hear you, Barry, if you're speaking.
Sorry, the classical thing, I was on mute. Thank you very much, Erin, for that on the LEO side of things. Can I just say, please, audience, bring, I haven't got any questions at the moment. If you have questions, can you please put them on the Q&A so that we can get them into the discussion. So let's move on now to the third panel member, Anton Monk from Viasat, who's going to talk, I guess, about geo satellites. Anton?
Thanks, Barry. appreciate the invitation to talk here. So yeah, I just have a few slides to talk about what Viasat does. For those that don't know, I will say that I will not be able to beat what I think has to be the line of the day already from Erwin, which is a router with a fuel tank. I think I'm gonna have to use that one in the future. Anyway, for we do quite a few different things. The company Viasat has been around since 1986. We've got about 6,000 employees, and I just out of interest touch on a few of the areas that we're focused on. Obviously, heavily involved in bringing connectivity to unserved and underserved locations, not just in the U.S. but around the world. I'll speak a little bit more about that and how we've consistently led the satellite market in terms of what we would call bandwidth economics, the cost per megabit per second served. So in addition to home and business internet, we also do enterprise services. We recently acquired a company called RigNet, and actually I think we now have the largest microwave cellular network over water because we serve oil rigs in the Gulf of Mexico. So that's a interesting, different, but critical application for those remote enterprise locations. I would say we are certainly, in our opinion, the leader in in-flight connectivity. That's taken a major hit in the early days of COVID, but coming back quickly. We supply 100 megabit per second plus service to American Airlines, United, Delta, Qantas, and so on. We have a maritime and land mobile, but certainly another ideal application for satellite. And then we provide solutions for rural cellular and Wi-Fi around the world. And then we have a large government and defense solutions business as well, where we don't just build our own GEO satellites, we actually build LEO satellites as well. We just don't run the service there. Next. Thanks. Just to give you a sense of some of the satellites that we have up. Erwin knows the second one well. He was one of the principals at Wild Blue, which is really one of the, or if not the first really broadband satellite providing consumer services. The big news for us is our Viasat 3 constellations, a global constellation we're launching early next year, and each of these satellites will have more than a terabit per second of capacity. So, you know, we don't traditionally have 2G, 3G, 4G, 5G in the satellite world, at least not publicly, but really the same pace of innovation that happens in cellular and Wi-Fi and unlicensed and other areas happens in satellite. It's usually more self-contained. Next slide. So I think, you know, one of the most important things with satellite communications is what we call the bandwidth economics. We've increased capacity over the years now by more than 500x. As I mentioned, the next generation of satellite will be more than a terabit per second launching next year. Next. But what that means is, as you can offer more capacity for the same price of putting up a satellite for these GEO satellites, you can decrease the cost dramatically. And it's those two components that allow us to serve the underserved that cannot all support the kinds of ARPUs that we see in kind of US applications or Western society. Next. And then I think one interesting thing about Viasat is that we're vertically integrated. We do everything from design our own chips to design and build our own payloads, pilot satellites, and run the service. And one other interesting thing is Viasat 4, already in the planning stages, will provide more than 5 terabits per second per satellite. So these are the Gs from our perspective, separate from 3GPP. Next. I think it's my last slide here. So just again, to summarize where we expect to be in the next few years is a global constellation of 3 satellites that we're launching, first above the US, then above Europe, Middle East, Africa, and then Asia Pacific. Very high, low cost per megabit per second with very long lifespans. So these, you know, some of the things that are different from GEO and LEO, not just the altitude, but the cost per satellite and the capacity per satellite. So I think that's all I have here. I think the conversation today, at least from our perspective, one of the most interesting pieces is 3D space. And is that the component of 6G that brings satellite into the mix? You know, how do we network? What do these heterogeneous hybrid networks look like? What's the value of having a HAPS platform with LEO, with GEO, to provide a blend of coverage, capacity, bandwidth economics, latency, resilience, and emergency type services. So I'm hoping that's what we'll spend some time talking about today. Thanks, Barry.
Thank you very much, Anton. We've had our three panelists talk a little bit about the non-terrestrial network assets, as it were. And now we can open it to questions. And I've got a few questions I can see coming through at the moment. So let's look at the first question, which was about integration. And the question was, how will integration be with terrestrial mobile look like in these future networks? Who'd like to take that one?
I think that's a big question, Doug. You know, I think there's lots of opinions, especially in the 3GPP NTN aspect, where some have this vision of connectivity everywhere, direct to cell phones. The question, and certainly there are companies that have been launched to integrate directly with space assets. I think the jury's still out on how effective that will be, and also whether it's integration with broadband communications or IoT. There's a number of companies that have been launched to serve 5G networks directly to IoT devices from LEO. Those might be more practical, I think. I'm just trying to focus on areas that are different from standard satellite backhaul, which many people know how to do. We do that as well, into what 5G or 6G means for these heterogeneous networks.
Anybody else like to comment on the integration of terrestrial and the space components?
And from our perspective, us being closer to Earth in any case, interaction with the terrestrial networks, and one of the, I think when you look at different asset class or categories coming into play, that also puts pressure on costs and how terrestrial networks will have to kind of be competitive enough that they will make sense as soon as you consider cell towers in the sky, right? Or how will also, one other aspect is consistent applicability of the network that you're providing. When you talk about aerial assets, there is aerial deconfliction, there is weather, there are various different components that come into play. Satellites might not get that impacted, but as soon as you consider assets that are flying persistently across different altitudes within the Earth's atmosphere, you'll have to do it in a combination with terrestrial networks, just so that you are consistent and there is no breakage in any kind of service that you're providing. And so I think it's a partnership. It's not either or. All of it has to come together.
Can I push you a bit in terms of the integration? I see another question further down, which talks about NFV and SDN as this system of being one giant software-defined network. And should we leave the HAPS or the satellites out of that, or should we be putting some of the functions on board the HAPS and on board the satellites?
So, Barry, I like to break that down a little bit as well, right? One aspect of it is, are you kind of putting a base station, the base stations that have traditionally been on ground, or are you creating somewhat of a bent pipe for data flow or connectivity? So there are two ways, or there are multiple ways, but two big ways that you would look at this. And as base stations or components that have traditionally resided on satellites become smaller, more power efficient, or the assets that you can put these on can provide the power requirements. For example, baseline, there is 1 kilowatt of consistent power that's required. Can an unmanned aerial platform that's flying persistently do that? Yes, that's where we are headed. But that there is multiple different considerations that come into play when you look at something like that.
And let me I'd like to make a comment about, we have opted after, a lot of, engineering and analysis to put essentially the hubs on board the spacecraft, right? And a lot of good reasons for doing that. One is that we couldn't figure out how to do a mesh network in space without putting the hubs and the routers on board the spacecraft. I mean, you look at, can you route analog over ISLs? Yeah, but it's ugly. So you really need to get the routers and the hubs of the spacecraft. The other challenge is, kind of the old adage, what goes up must come down. And the problem you've got is that, if the weakest link in a satellite network is always the satellite to the user terminal. And if you have a bent pipe satellite, by definition, the link from the satellite back down to the Earth station is equally as weak. And by putting a router and the hub on board the spacecraft, you can demodulate, you can remodulate, you can multiplex all that data together, and you can run super efficient big fat pipes, down to Earth stations. And so I just can't imagine that next generation LEO systems would do anything other than full onboard processing.
I'll add one other practical thing. I'm not sure this is a 6G comment really, but I think distributed features in the packet cores are critical for certain aspects for GEO. For example, just due to our latency constraints, we have to do various TCP acceleration solutions, and you have to be able to break out, have local breakout of the data plane in order to achieve some of those. So having distributed packet cores, again, is very practical. It could equally apply to 4G, not just 5G or 6G. But other than the more advanced stuff that Erwin and Fatima are talking about, having that trade-off between functions in the cloud and locally, especially for these rural locations, is critical.
Okay, thanks very much for that. I see one or two questions which are centered around technology, and questions about, well, what technologies do you see these non-terrestrial networks having in the future? What are the key technologies that you should be driving your people to produce for this 6G environment? Would you like to take that up? Technologies. No takers?
Well,
here, I'll volunteer.
Okay.
There's 4 technologies that we've been very focused on, and I think they're really the 4 technologies that are going to fuel the next revolution or next extension in space and terrestrial technologies. There's just digital semiconductors, the ability to do massive onboard processing in space. And I mean, I don't know how many teraflops we're doing on board these days, but I certainly never imagined, that in my career you'd be able to digitize, directly, tens of gigahertz of bandwidth, do everything digitally, D to A it back into analog and shoot it back down to the ground. And that's doable today with a reasonable amount of weight and power, and I expect there'll be an order of magnitude more. Microwave, semiconductor technology, gosh, we were thinking we could get to 10% efficiency, 10, 12 years ago. That'd be great. Now we're talking 20 and 30% efficiency. It'd be great if we could get to 50 and 75% efficiency. Solar arrays are up to 30% now. Maybe they'll go to 50 as well. Optical technology, incredible what optical technology could do. Electric propulsion. I mean, there's some really cool technologies that are allowing us to do things that we didn't think we'd be able to do even a decade ago.
And Erwin, that actually brings in, from a technology innovation perspective, right? Battery technology, power management. Today, when we're talking about our unmanned aerial platforms flying persistently for weeks and months at different altitudes, our ability to fly at near stall speeds, which means when we're flying in the stratosphere, we're flying essentially with low air density on the wings. And that's why these assets can now fly persistently for months. Along with that, so power management is a key part of this. And then as you're growing in technology processing capability, you touched upon optical comms. When you look at secured networks, and I know this is going slightly beyond the 6G world, but actual optical comms with stable assets has never been possible. But today, when we're working with the likes of CACI or Lucent Technology, which is part of CACI, and optical comms is becoming a reality, truly secured comms, enterprise comms over high bandwidth becomes a possibility. So when we are looking at the future of technology and software-defined radios and how some of those will come in, how the phased array antennas are being modified with the likes of Motorola and others, and how they get integrated into all of this. So there's a lot of technology advancement that is happening in making it smaller, faster, more power efficient. And that's what's going to revolutionize a lot of these things.
If we could stay a little bit there with optical comms, and it was mentioned, Erwin mentioned about optical comms between LEOs and so forth. What about optical comms from the Earth to the HAPS or the Earth to the satellite on feeder links, etc.?
So right now, Barry, as we're looking at it, I think it's more aerial to aerial asset optical comms, because essentially you're beaming, right? You need stable. If it moves too much, you are going to lose that connectivity. And so initially, even if we're able to achieve it between aerial assets and transmission of data, that's the first step. And then as these assets become more stable, then you're talking about the future. And optical comms has been, the flex capacitor of our world for a long time now. And I obviously dated myself as soon as I mentioned the flex capacitor, but but that is definitely something that we are exploring as aerial assets that are flying long durations and beyond line of sight.
Yeah, I would echo some of that as well. Thinking about technology components, massive processing in space, not just space, but ground segments as well, to increase capacity. Free space optics for things like feeder links in the future, I think, is a big challenge, but would remove that capacity constraint. Phased array antennas, no surprise there. A big item which Fatima touched on cybersecurity related, especially for government systems. 5G and 6G is operating through basically zero trust networks. So that's a hot topic. And of course, just software-defined networking, expanding to space-based as well as ground-based, to be able to hybridize these networks and switch between different 3D segments.
And I'd like to add too, people of my generation tend to think of technology as hardware, something that you can hold in your hand and plug in the wall or attach in a rack. But more and more of our technology is becoming software, and the sophistication around writing software and testing software, maintaining software, and the network we're building has highly distributed intelligence. It's not a lumped intelligence network, and building a system with many, many nodes, and the nodes are incredibly intelligent, and they cooperate, in a self-optimizing way with all their neighboring nodes. That's cool stuff, and that's technology. And I think sometimes we forget that technology is not all about the hard stuff. It's the soft stuff. And by the way, the soft stuff is a bit hard sometimes.
And Arvind, you touched upon it very well. I think I mentioned it earlier, right? And Anton, as you mentioned, it's a coordinated effort. In the ISR intelligence surveillance world, we talk about tipping and queuing, or the ability to hand off and smartly hand off, even in networks. So that is exactly what right now for the Air Force, but that we're doing, and it's a software solution. It's not a hardware solution, but it controls the software. And that's where open architectures and truly open systems come into play, so that internetworking and handoff can happen. So you're optimized, what is the bandwidth you need to cover? What is the area you need to cover? How many assets are needed, and where data will be handed off? If your systems are aware of it in a smart way and are able to do it fully autonomously, that's when we will be able to talk about the next generation of networks. And that's what exactly we're doing swarming for. It's for communication. How are we swarming smartly for communication? It's a software solution. It's not a hardware solution.
Okay, I'm looking through the questions that we've got on the Q&A here. There's quite an interesting question here about which says, can you expand on the cognitive satellite? I don't know who mentioned the cognitive satellite, but I mean, it's an interesting question. Anybody want to take that up?
Sounds like an Irwin question.
I'm not sure.
Owen, was it you? Cognitive satellite?
I don't think I use the word cognitive, but
Okay.
but we're certainly building very smart satellites, and I think satellites are going to get smarter and smarter in the future. And as I was saying, is that the ability to put a huge amount of intelligence on a spacecraft and have it, all of the adaptive modulation and coding and routing and switching, prioritization of traffic, self-recovery of faults, working around, if an adjacent satellite fails, can you, automatically route around it? Can you, automatically have the satellite point the laser link, not just at the adjacent satellite, but shoot over that one and hit the next one and reconnect the network, self-healing. I think that's the world that we're moving forward into. I think as we put up hundreds and others are putting up thousands of satellites, you can't have thousands of people managing your network. Your network has to manage itself, and a small handful of humans can deal with with anomalies that the self-healing network can't cure. But that's got to be the future.
And Irvin, that's what we were referring to as software solutions, right? That's where swarming assets, not just satellite, but actually lower assets as well, comes in.
I think cognition is something in my realm that I've come across, particularly in terms of the spectrum and interference, where we might have cognitive networks to actually sample the interference, etc. And it does, beg the question here. We haven't talked about interference as to how all these systems can coexist, and how we're going to manage interference. Because as we go, as we move above Ka bands, there's no exclusive bands for satellites and HAPS. So essentially, we're going to have to share with terrestrial. Everybody in the space sector's got to share. So how are we going to do this? How is interference going to be managed?
Barry, I think I mentioned earlier, we were in discussion with one of the larger wireless service providers here in the US, and essentially being able to manage it at altitude, different altitudes having different types of interference, and the system. So when you think about cognitive ability to manage around it, that if you are going to be flying 1,000 AGL above ground level, what kind of interference you're going to get with what kind of base station you're carrying, and then the systems being rerouted. And obviously at the satellite level, I'll let Irvin and Anton kind of provide some background as well, but there are different deconfliction that needs to be built in smartly into systems.
I think with interference as well, we're seeing several constellations now coming up in low Earth orbit, all using very similar frequency bands, etc. So you've got an interference situation there. How are we going to manage that?
So, we do it through software, amazingly. But certainly, number one is we have to protect the geo orbits. In most cases, many of the frequency bands that we use are shared with geo. And so certainly our for any given user terminal on the ground, we have some number of satellites, 6, 8, 10 satellites that could actually serve that user at any given time. And so for user terminals that are near the equator, you always want to point north or point south. You want to be real careful pointing east and west or straight up. And so the intelligent resource management system will make certain that terminal is attached to a satellite such that the line of sight doesn't interfere with geo. For other satellites that are in our frequency band, we have relatively narrow beams. And so we know where other satellites are. And again, we can assign resources among the various satellites that are visible so that we can provide a high quality of service and at the same time, efficient use of our spectrum, but avoid interference.
So I guess cognition is coming into this with artificial intelligence and how you manage this very complex situation.
I mean, that's a part of it. I would say you mentioned one aspect of coordination, and that's spectrum and interference coordination. There's another question that came up, and I think it's not really a 6G thing, but it has to do with these large constellations, and that's physical coordination and space debris. So it's not just the soft aspect of spectrum coordination, and I think there's some amount of it you can do through cognitive radios and so on, but there needs to be protection for existing assets. And it's not just a future 6G thing. This is a Ka band problem right now with ITU and reducing the potential for interference with existing solutions and planned solutions. But the physical coordination for space debris is a huge problem that we see with all these large constellations that are being put up. I'm not talking about the 300 constellation size that Erwin is talking about. That seems pretty reasonable compared to the tens of thousands that others are talking about. And there's currently no coordination at all. Like we're used to the ITU coordinating orbital slots for GEO, but when one regulatory body gives authorization for 10,000 satellites and that affects space for the rest of the world, that's a much more challenging discussion.
I agree, that's a real problem.
Yeah, especially if it has the potential to affect space and space communications and satellites for tens, if not hundreds of years.
Can I move on to another question here? I've got a question which says, if we were able to put routers and edge processing units in space, does it create a different non-national environment for regulation? And or does it create fresh opportunities for services? So we're back to this question of, putting other more networking assets around into space around these assets. And does this actually then create a completely different environment? And how do you regulate that environment?
So Barry, regulation is a very interesting thing. It's not just when we're talking about the LEO or GEO assets, even stratosphere. There is a lot of regulation. So for example, when you look at airspace, whether that be FAA or ICAO or others, but if you look at the stratosphere, which is considered between the 65 to 85,000 feet above ground level, currently it's kind of no man's land. As long as you reach that, there is no regulator, no specific. People are now starting to take a look at it. Or when we, Anton will be able to shed more light on it, 3GPP, it was all from a regulatory perspective. And then if you think about edge processing capability, one is network management, but data is part of this conversation and how you're going to be managing data. Today, when you work with Germany, Germany doesn't allow anybody to transport any kind of data outside of Germany. But what if you are in the stratosphere, and how are you going to be transmitting some of that? So there are layered angles that we will all collectively as the industry have to come together and start laying down the foundation for it. That's one of the reasons why HAPS Alliance was actually initially created. Regulatory aspects were a key part of it.
Okay, maybe turn on to another question. This is a question about IoT. Can you talk about IoT device transmit power required to reach the various layers of satellite services? Also, how will this impact on the cost of the IoT devices themselves? So we're into the IoT area. I mean, more generally, do you think the IoT area is a big market for satellites and HAPS? Is it something that we should be pushing? And what about these devices? Do they have enough power to reach the various satellites or HAPS?
Well, the market is happening regardless. I mean, there's certainly a market for that. I think the bigger question is there's so many companies, especially LEO to IoT companies, that have been started in the past few years. I think nobody really knows yet what the shakeout is going to look like. There's no way that that tells you that there is a market, but it's a market that's very, very low average revenue per device. And so the economics are absolutely critical. And then you've got your custom waveform solutions, but then I've seen at least 2 companies that are talking about 5G waveforms to 5G IoT devices, which I think is probably more realistic than 5G waveforms to broadband smartphone type devices, at least in terms of the technology requirements.
Is this something that will only work with low Earth orbiting satellites or HAPS? How about
do you mean for 5G waveforms? No, I mean
no, for IoT. For IoT,
there are
thinking about transmission from IoT devices.
There are IoT solutions I think it fits into many different categories. You can have a local hub servicing an agricultural farm or something like that, and that's transmitting through that hub over a more traditional satellite link. So I would say that's still a satellite IoT type application, but local distribution is not satellite.
But as Anton says, I think the economics of certainly space-based IoT involves a lot of scale. I mean, if you're going to charge $1 a month or $2 or $3 a month for a service, I mean, you need certainly millions of customers to generate a reasonable amount of revenue. And so I think that doing it with 1 or 2 geo satellites might not be very effective from a scale point of view. I think most of the systems being proposed are using smaller LEO satellites, and they're mostly using stuff in the hundreds of megahertz up to kind of L-band type frequency bands. Again, just looking for kind of zero atmospheric loss and very, very, very low cost transmitters. Our system, I mean, at Ka band, it's kind of less effective to use that bandwidth for small IoT devices, but we can operate very effectively as a hub. That if you've got a ground-based tower with several thousand IoT devices connecting through it, cows or sheep or whatever other IoT devices you want to hook up, we can provide a super efficient way to backhaul that data and connect it back into the world's kind of public networks.
I just want a quick segue there, because Erwin mentioned some ARPU numbers. I think it's worthwhile level setting on this, where the world really is, the majority of the world, the 3 billion unconnected, because we do serve those customers. And unlike the $50 to $120 ARPUs you can expect in remote locations in the US, if you go to Africa, I'm not even talking about Mexico, where you can get $4 a month ARPU. These are the real world problems. Places like Democratic Republic of Congo, which is one of the biggest countries in Africa, $1.50 is the average revenue per user. You go to Tanzania, it's $1. So for them, most of those networks are 2G with some 4G. For them, the future is 4G, and we're talking about billions of people. So I think it's worthwhile level setting. Yeah, we're talking about 6G here, but there's a lot of things that have to be solved in the world. A lot of opportunity that all come down to bandwidth economics. The cost of the internet system.
Okay, sorry, Fatima. Yeah, go ahead.
No, I was just going to say that is a critical point, even from assets within the Earth's atmosphere. How do you make it from a business perspective more effective as you compare it to terrestrial networks? So that's where I think the cost aspect of the underserved is going to be so critical. And what other use cases are you serving along with that, so that you can optimize and spread the cost across various different use cases, not just enabling the network?
We're coming towards the end of this session, actually, but there are 1 or 2 questions. I was trying to wrap them up in a way about using what spectrum will be used, how will the satellite network operators and the mobile network operators, etc., come together in the future. I wonder if you could just briefly sort of see whether you feel this kind of integration and this 3D networking thing will change the business model. And how will it come together? Or in 10, 15 years' time, will we still have LEO, GEO, HAPS operators separately? perhaps we could do that. Fatima, would you like to start off? And then I'll get the other two, and that's about the time we'll probably have.
I think we've covered quite a lot of some of this as well, Barry, but I think we will absolutely have to work with various different providers, and the mobile operators are a key part of this conversation, right? And they are the likes of Deutsche Telekom and others have experimented with different components and how all of this works together for long duration. They're part of the HAPS Alliance as well. And it is key that we, when I said I've come from Cineverse, which is actually an organization that solves for complexity in the networks. And that was the key part. One area doesn't talk to the other. So open standards, truly open standards, and bringing the likes of NATO and others into the discussion is also going to be critical as we look at it as a global solution.
Okay, Erwin or Anton, want to comment?
I think, I mean, your question, will we have LEO, GEO, MEO? Yes, I think we will for a very long time. You know, we Telesat, we operate a fleet of 15 geostationary satellites today. We cover most of the planet, except for the far north and the far south that can't see very well from GEO. You know, we still have a very healthy business. I think more and more broadcast will be done via GEO, where, you know, latency is not a factor. But I certainly don't imagine the GEO business going away. There's some cool things you can do from MEO as well, and certainly GPS is not comms exactly, but that's a great place for that type of technology. O3B and they've carved out a nice niche business in MEO, and I think that there will be comms in MEO for a long time. I think you know, there's a lot of excitement today in LEO, and I think a large portion of two-way SATCOM will be in LEO. You know, where the latencies are such that two-way packet communications is much more effective. And I think HAPS may I'm less certain about HAPS, and Fatima can speak to it better than I can. But I think there'll be a niche where those technologies you know, are kind of ideal. But I think it's less certain, certainly in my mind, as to how that'll evolve over the next decade.
Yeah, I would say it's no question there's going to be place in space for, you know, all of these options. I think there'll also be consolidation in the market at some point, just because of the different requirements. If you look at government requirements for resiliency and, you know, tactical kind of battle space applications, you're going to need multiple segments of space and ground networks, and that's all about hybrid network is hybridization of networks and SD-WAN solutions, and zero trust type applications, especially in 5G solutions where, you know, there's a commercial networks potentially. So I also think it's not A, B, or C. It's a massive market here. It's a massive market of unconnected, underconnected, unserved. So I think it's plenty of room for multiple options.
Okay, I think we're just about out of time, so I should bring the panel session to an end and thank very much the three panelists, Fatima, Erwin, and Tom, for your contributions. I think we've answered the majority of the questions. There may be one or two that I didn't get around to in the time, but I hope we've given you a very good picture of non-terrestrial networks in the future, and some of the technologies that actually will play a part in 6G. So thank you very much, and thank you very much to the panelists again.